Hi there, welcome to my channel. Hope you are doing well. In today's video, we are going to solve this first lead code problem to sum. Let's understand the problem first. They are saying given an array of integers, nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input word have exactly one solution and you may not use the same element twice. You can return answer in any order. Let's understand the problem from the example itself. Here nums is 2, 7, 11 and 15 and the target value is 9. Now we need to find out which elements will add up to 9. So they are already given that there will be exactly one solution. So whenever there we have found one pair of such elements which adds up to 9, we can return from there itself. In this scenario, we have 2. If we start from 2, 2 plus 7 is equal to 9. So from here itself, we can return that elements at index 0 and index 1 sums up to 9. This will be our answer. The example 2 has 3, 2, 4 and target is 6. Now in this case, if we sum up first two elements 3 plus 2, it will be 5. If we sum up first and third element 3 plus 4, it will be 7. But second and third, these elements will add up to 6. Output is 1 and 2, which are the indices of these two elements. In example 3, we have two elements 3 and 3 and target is 6. In this case also, if we add up 3 and 3, the result will be 6. Hence, we will result 0 and 1, which are the indices of these two elements. The constraints are the length of nums should be between this 2 and 10,000. Then we have the constraint over the values of nums I and then the target. Main thing here we need to focus is this. Only one valid answer exists. So there will be one answer and there will be only one answer. Those two things we need to keep in mind, that answer exists and only one answer exists. The follow-up is, can you come up with an algorithm that is less than order of n square time complexity? Let's discuss the approach now. Now, one of the simplest brute force approach would be, we will start with one element, say 2 in this case, and then we will check all the other elements if 2 is able to make up the target value with any of the other element. In this case, we will start with 2 and then we will check 7. 2 plus 7 is 9. So we can return the indices from here 0 and 1. Let's see the other variation. What if instead of 9 the target was 18? Now first we will start with 2 and see if any other element is able to make 18 with 2. So 2 plus 7 is not 18, 2 plus 11 is not 18, 2 plus 15 is not 18. So we need to move further because with 2 we are not able to make any such pair. 7 plus 11 is 18. So we have a valid pair here which is at location 1 and 2. So this will be our answer. Using this approach, what we are doing, for each element, for example 2, we are traversing over all other elements for the array. Then for 7, we will again traverse over all the remaining elements. It will take 2 loops to do this thing, and having 2 loops will result into time complexity of order of n square. And we just read in the follow-up that we should try to solve it in time complexity less than order of n square. Let's see some other approach now. Other approach would be to maintain all these elements in HashMap along with their indices. So when we are traversing through the array, we will check if the element we are looking at, for example 2 in this case, if complement of this element with respect to target already exists in the dictionary. So if it exists, then we will return index of this, for example 0 in this case, and the index of element from the dictionary itself. Let's understand this approach with the help of example. We will start with an empty dictionary and then traverse the array. At first we encounter 2. We checked in dictionary if there 9 minus 2 already exists. 9 minus 2 is 7, which is not there in the dictionary. As of now it is empty. So we have not found a perfect pair. So we will add this element 2 to dictionary along with its index 0. Let's move to the next index. Now we are at 7. So at 7 we will check if 9 minus 7, that is 2, already exists in the dictionary. If yes, yes, it exists. If yes, we will return the index of this 7, which is 1, along with index of element from dictionary, that is 0, from the function. So our answer would be 1 or 0. As already stated in the question, the answer can be in any order. It could be 0 or 1 or 1, 0. Both will be fine. Let's see the other example. Here array is 3 to 4 and target is 6. So we have already defined an empty dictionary here. We will start traversing the array. We found a 3 here. Now 6 minus 3, that is 3, is not available in the dictionary. Hence no perfect pair is found here. We will move to the next element. But before that we will add this element to dictionary. So 3 along with its index, that is 0, is added to dictionary. After this we have reached this index. Here value is 2. Now we will see if 6 minus 2, that is 4, is available in the dictionary. No, it is not there. We have to move next element now, but before that we will add this element to dictionary. 2 along with its index is added to dictionary. At last element a 4 is there. Now we will see if 6 minus 4, that is 2, is there in dictionary or not. So it's already there, it's here. In that case we have found a perfect pair and we will return that. We will return 1 comma 2. 1 is the index of element 2 and 2 is the index of element 4. That's how we will solve this problem. Let's try to code the solution now. First we will define an empty dictionary. Say its name is pairs. Now we will traverse over the array. While traversing an element, first we will try to find out if that element's complement already exists in the dictionary or not. For that we will do if target minus nums I in pairs.keys. Then we will return the pair of indices for both the elements. One we will pick from the dictionary for the element target minus nums I, the complementary element, and other is I itself. If the pair is not found, then we will add the element to the dictionary. So as question already suggested that there will always be a solution to this problem and only one such pair exists, we will be able to return our solution from here itself. But following the standard coding practices, we will have an empty return statement here. Let's try to run this code. The sample test cases worked fine. Let's submit this. Solution is submitted successfully. Let's have a look at its complexity. In this case, we are defining a dictionary which will take linear space. So its space complexity here would be order of n. In the next step, we have a loop which will run length of nums times. So its time complexity would be order of n times again. These all our operations will take order of 1 time, hence I'm not considering this. So in totality, this complete solution takes space of order of n and time also of order of n. This is all about this problem. If you have any suggestions to enhance this particular solution, or if you have any other better solution, please let me know in the comment section and visit my channel for more such videos. Thank you so much. See you soon. Bye.